All right, let's go over questions in quiz 6. The first question is about this molecule. What is the molecular formula of a substance made of this type of molecule? Okay, so you're given a line structure. Whenever you have to do the line structure, I suggest that you convert it to a Lewis structure. And how do we do it? To convert line to a Lewis structure, we need to replace our ends and bends with carbons. Okay, for example, here's a bend over here, that must be a carbon. Another bend, carbon, 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 carbon. Here's an end. Okay, there's a carbon there as well. Carbon, 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 and carbon. Okay, now once you have replaced the ends and bends with carbon, you need to fulfill the common bonding pattern of carbon using carbon hydrogen bonds. Okay, so let's do that as well. If you look at this carbon over here, we already have 4 bonds around it. The common bonding pattern of carbon is 4, therefore we have to do nothing about this carbon. Same thing goes for this carbon. We have 4 bonds, we do nothing. This carbon over here has only 2 bonds, therefore we need to add 2 carbon hydrogen bonds to fulfill the common bonding pattern of carbon. This carbon has 3, therefore we need 1. This has 2, therefore we need 2. Okay, we have 1 here, therefore we're going to need, we have 3 here, we only need 1. This carbon has only 1 bond, therefore we're going to need 1, 2, 3 bonds to fulfill the common bonding pattern of the carbon, and only 1 here because we already have 3, only 1 bond is needed. And then on the other side, this carbon is good, and for this carbon I need 1 more hydrogen. We need 2 more bonds for this carbon, and okay, 2 more here, and then 2 more here. Okay, and for last carbon over here, we have 2 bonds. Therefore, we need to add 2 more carbon hydrogen bonds to fulfill the common bonding pattern of the carbon. Once you do that, only thing left is to make sure that all the elements, all the atoms have an octet of electrons, okay, except for the hydrogen, because hydrogen can only have 2 around it. All the other atoms must have 8 electrons around them. For example, if we take this oxygen atom over here, we only have 2 bonds, therefore we're going to need 2 lone pairs to fulfill the octet around that oxygen. Okay, because 2 bonding electron pairs plus 2 lone pairs means 8 electrons around it. Okay, this oxygen over here, same scenario, we only have 2 bonds, that means 4 electrons. We're going to need 2 lone pairs to make an octet around that oxygen. Same situation over here. Okay, and this oxygen again has only 2 bonds, that means 4 electrons. We need to add 4 more electrons in terms of 2 lone pairs. Okay, right now we have completed the Lewis structure. We have converted our line structure to a Lewis structure. Then what we need to do is we just need to count the atoms now. Let's start by counting the carbon atoms. We have 2 options, 14 and 15. Let's see. Okay, now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 carbons. Okay, let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 carbons. Therefore, we can eliminate any option with 15 carbon here. So we are left with only two options. Right now, we need to decide whether we have 19 hydrogens or 20 hydrogens. That's the question. Okay, so let's count the hydrogens. We have one hydrogen over here. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 hydrogens. Therefore, our correct answer must be option C. Okay, so I'm going to mark my answer. Right, and so what I'm going to do is I'm going to leave the Lewis structure over here because I think I'm going to need that for some other questions as well. All right, let's move on to next question. Okay, again with the same, it's not the same structure, it's a different structure, but that's okay. Let me get rid of my the previous structure. Okay, let's deal with this now. What is the electron pair geometry around the atom Mark II? So here's the atom Mark II. Okay, again, what we have is a line structure now. Okay, we have three bonding electron pairs around three bonds around nitrogen. That means three bonding electron pairs. That means 6 electrons. We need 2 more electrons to fulfill the octet on that atom. Okay, therefore we're going to add a lone pair. Okay, now we have an octet of electrons. Now, when it comes to electron pairs, so electron domains, electron domains in this case, pairs in this case, we have 1, 2, 3, 4 electron domains. Okay, if you have 4 electron domains, they're going to arrange in a tetrahedral geometry to minimize the repulsion between them. Therefore, the electron domain geometry or the electron pair geometry in this case is going to be tetrahedral. Again, it's very important that you go from line structure to a Lewis structure before you determine the geometries. Right, let's do this problem over here. This question, how many double bonds are present in the molecular structure of C3H4O3? Assume all atoms satisfy their common bonding patterns in this molecule, and carbon atoms are bonded in linear chains. Okay, so I think there are many possibilities here. We can draw at least 2. So carbons are bound to each other. So we have 3 of them, and then we have 3 oxygens. Okay, let's do it in a simple way. Here are my 3 oxygens. Okay, and then I only have 4 hydrogens. Okay, so I'm feeling that I can make a few of these oxygens double bonded. Okay, oh, let's start with this. Okay, let's say that we have a double bond over here, and this should be a hydrogen. Okay, and then there's another double bond over here. If that is the case, these 2 carbons have fulfilled the common bonding pattern. In the last case, I'm going to need 2 more carbon hydrogen bonds to fulfill the common bonding pattern of this carbon, and then another hydrogen over here to make sure that we have an octet around this oxygen as well. Okay, octet of electrons around this oxygen as well. Remember, we have the lone pairs to go with these oxygens to fulfill the common bonding pattern, the octet. Okay, so I fulfill the common bonding pattern of oxygen by adding this hydrogen bond, oxygen hydrogen bond, and then to fulfill the octet rule, I need to add the lone pairs to make sure that all the elements except for hydrogen have an octet of electrons around them. Right. Now we have, based on this, we have 2 double bonds in this structure. Let's draw another one. Okay, this time I'm going to have a double bond in carbon. Okay, let's say that we have this situation. We can only have 1 double Yeah, let's say we have a double bond over here, and then if that is the case, I can have carbon double bond oxygen over here, and then maybe an OH here. It's one hydrogen, okay, and then one more oxygen, and then one more hydrogen oxygen bond to fulfill the common bonding pattern of that oxygen, and then we have one more hydrogen. Okay, so I have fulfilled the common bonding patterns of all the elements, and also I have three oxygens, three carbons, and then 1, 2, 3, 4 hydrogen atoms. Okay, now again you can see that we have only two double bonds. So whatever the structure you come up with, okay, we can come up with more possibilities. You're going to see two double bonds in the structure. Two over here. Okay, now moving on to question 4. What is the molecular geometry around the atom mark II? Okay, again, we are dealing with this nitrogen over here. Okay, so we need to keep in mind that we have to have an octet of electrons around these atoms. Therefore, we need to add a lone pair. We only have 3 bonding electron pairs. That means 6 electrons. The other 2 electrons should come in terms of a lone pair. So I'm going to add that. Okay. Now, the electron domain geometry is tetrahedral because we have 4 electron domains, but only 3 of them are bonding electron domains. As a result of that, they're going to arrange in a trigonal pyramidal geometry. Okay, so let me try to draw that. This is one nitrogen carbon bond, and then the other bond should come out at you like that, and then the next bond should go into the plane. Okay, so we're going to have a trigonal pyramidal geometry. So I'm going to click on that. Okay. Nitrogen. Okay. Let's do with discussion. Which of the following is the Lewis structure of H and S? Okay. Now, if it's a Lewis structure, the most important thing is to have an octet around each of the atoms. Okay, and also to make sure that the central atom is the one with the higher bonding capacity, and then the highest bonding capacity, and then we have the octets around each of the atoms. Okay, so in all 3 cases, all 4 cases, nitrogen is the central atom, which is great because it has the highest bonding capacity out of these 3 elements. Hydrogen is 1, sulfur is 2, and nitrogen is 3. Therefore, it is in the middle, which is great. Now let's count the valence electrons. In structure A, we have 8 electrons for sulfur, and 1, 2, 3, 4. 8 electrons for nitrogen, and then hydrogen has 2 electrons. So A sounds good. Now when it comes to structure B, we have 2 bonding electron pairs around nitrogen and only 1 lone pair. Therefore, we only have 6 electrons around nitrogen. Therefore, option B is out. We don't have an octet on nitrogen. Okay. When it comes to option C, I have 2 lone pairs and then 3 bonding electron pairs around this nitrogen, making it have 10 electrons. So we have violated the octet rule, but that is out. When it comes to option D, the same scenario, we have 1, 2, 3, 4 bonding electron pairs and then 1 lone pair, altogether 5 electron pairs, therefore 10 electrons. Violating octet rule is not going to work. Therefore, the correct answer must be option A. Okay, and moving on to this is our last question. Based on the Lewis structure of SF2, the first thing is to draw the Lewis structure. Okay, so draw the Lewis structure of SF2. I'm going to have, okay. So again, if you start from the basics, sulfur has 6 electrons, and then fluorine has 7, sulfur has 6 valence electrons, fluorine has 7 valence electrons, so I have 2 of them. Now altogether we have 14 coming from 2 fluorine atoms, so we have 20 electrons. That means 10 electron pairs. Okay, then what we do is we're gonna draw the skeleton of the molecule. Okay, in the skeleton of the molecule, the atom with higher bonding capacity goes in the center. Therefore, sulfur must be at the center. To that, we should have 2 fluorine atoms bound. That's our skeleton. Okay, now what we do is we have 10 electron pairs. We're going to distribute these 10 electron pairs starting with the outer atoms. Okay, we have already used 2 of them for these bonding electron pairs. We have 1, 2. Now, for if we add the other lone pairs, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we have till 8 electrons around each of these fluorines. Okay, therefore 9th and 10th lone pairs must go on to sulfur. And as you can see, now we have fulfilling the octet for all 3 atoms. Therefore, this is going to be a Lewis structure. Okay, now once you have the Lewis structure, let's tackle this problem now. What is true about the central atom in this molecule? It is surrounded by 2 bonding electron pairs and 2 lone pairs. 2 bonding electron pairs and 2 lone pairs. This is correct. It is surrounded by 1 bonding electron pair. No, we have 2 bonding electron pairs. So B is incorrect. It is surrounded by 3 bond. No, it is surrounded by 2 bonding electron pairs, not 3. It is surrounded by 4 bonding electron pairs. No, that is incorrect as well. The only correct answer is option A. So use that. Now we are done with this quiz. So let's submit and see what beautiful things about our answers. Okay, so we got all of them right. Okay, hope this helped. I'll see you guys later in the classroom or during office hours. Bye, everybody.